In this video, we're going to start the KutaSoftware Infinite Algebra 1 free worksheet solving equations by completing the square. Now this worksheet has a total of 24 problems, so I'm going to do 8 problems in each video. And in this first video, lucky enough for us, for the quadratic ax squared plus bx plus c equal to 0, we're only dealing with a values of 1. So because a equals 1, in order to complete the square, that means that we need a c value equal to b over 2 squared. And if you remember a few worksheets ago, we did a video just on completing the square. So if you're confused on this formula, refer back to that worksheet. I'll leave a link in the description below so you know how to access that. Now, another important thing to note, that because we're solving these quadratics and we're completing a square, essentially we're going to create a plus b squared or a minus b squared. So I'll write down the formulas for those real quickly. A plus b squared is equal to a squared plus 2ab plus b squared. And a minus b squared is a squared minus 2ab plus b squared. So just remember that when you're adding a and b, you add 2ab, and when you're subtracting a and b, you're subtracting 2ab. So now let's go over the steps for solving each equation. I know that this c value does not equal b over 2 squared. So what I'm going to do is I'm just going to add that to the other side. So I'll have a squared plus 2a equal to a positive 3. Now I'm going to create a c value that equals b over 2 squared. So if my b value is equal to 2, then c is going to equal 2 over 2 squared, which is 1 squared, which equals 1. So now to this equation, I'm going to add 1. So I'll have a squared plus 2a plus 1. But since I added 1 on the left-hand side, I'm going to also need to add 1 to the right-hand side in order to not change the value of the overall equation. Because of that additive inverse property, c plus a negative c equals 0. So when I added that c value of 1 in, a squared plus 2a plus 1, I also needed to take it away. So I also subtracted 1, and that was equal to 3. Then, if I was to add 1 to both sides, you can see that's where I'll get my 3 plus 1. So adding c, whatever I do to the left, I need to do to the right, does not change the value of the equation. So now you can see that a squared plus 2a plus 1 is in the form of a squared plus 2ab plus b squared, where that b value is 1 and the a value is simply a. So I'm going to rewrite that as a plus 1 squared, and that's going to be equal to 3 plus 1, which is 4. Now that I've completed the square, on the left-hand side of my equation, I can just take the square root to get that a plus 1, because the square root of a plus 1 squared will cancel out to be a plus 1, and that's going to be equal to the square root of 4, which is either a positive 2 or it's going to be a negative 2, because remember, a negative squared is also a positive, and negative 2 squared is equal to positive 4. So now I'm going to subtract 1 from that first equation to get that a is equal to a positive 1, and I'm also going to subtract 1 in the second equation to get that a is equal to a negative 3. So when I solved this equation by completing the square, I got my solutions as 1 and negative 3. So 1 and negative 3 are my solution in number 1. And I just wrote those in set notation. A equals 1 and a equals negative 3. Let's continue on to number 2. In number 2, as opposed to adding 8 to both sides at the start, I'm going to focus on my c value. So I want c to equal b over 2 squared. And in this case, my b value is equal to a negative 2. So now I'm going to have negative 2 over 2 squared. Negative 2 over 2 is a negative 1, and when I square that, I get positive 1. So I'm going to add this positive 1 and subtract that positive 1 in my equation in number 2 so I don't change the value. So I'll have a squared minus 2a, and then I'll add 1 and subtract 1, essentially adding 0, and then I still have to have minus 8, and that will equal 0. Now, a squared minus 2a plus 1 is in the form of a squared minus 2ab plus b squared. So I can rewrite this as a minus b squared, where my a value is simply a, and my b value is that positive 1. So I'll have a minus 1 squared, and then I'll combine my like terms, 1 and 8, to get minus 9. And that is all equal to 0. So now I'll move that 9 to the other side by adding 9 to both sides to get that a minus 1 squared equals a positive 9. You can see that that's the same value on the right-hand side that I would have gotten if I added 8 and then added 1 to both sides, because 8 plus 1 is 9. Now, my next step, I'm going to be taking the square root of both sides. So I'll get that a minus 1 equals a positive 3, since the square root of 9 is positive 3, and I'll also get that a minus 1 equals negative 3, since negative 3 squared will also give us a positive 9. So I'll add 1 to both sides in my first equation to get that a equals positive 4. And then I'll add 1 to both sides in my second equation to get that a is equal to a negative 2. So my solutions in number 2 are 4 and negative 2. So by adding c to both sides, essentially we're adding 0 to the equation. Let's continue on with number 3. I'll complete number 3 like I did in number 1 by moving this constant to the right-hand side at the start. So I'll add 22 to both sides. So I'll have p squared plus 16p equal to a positive 22. Now I need to complete that square on my left-hand side. My b value is a positive 16. So c is going to equal 16 over 2 squared, b over 2 squared. 16 divided by 2 is 8, and 8 squared is equal to 64. So I'll add 64 to both sides. So I'll have p squared plus 16p plus 64 equals 22 plus 64. So now I'm in the form of a squared plus 2ab plus b squared, where a is p and b is a positive 8, since 8 squared equals 64. A plus b squared. And that's equal to 22 plus 64, which equals 86. Now I'm going to need to take the square root of both sides, which will give me two separate equations. I'll have p plus 8 equal to the square root of 86, and we'll do the positive square root of 86, which is 9.2736, which I will round to 9.274, although on the answer key they had rounded that to 9.273. So 9.274, because I'm rounding up, and then I'll have p plus 8 equal to a negative 9.274, because negative 9.274 squared is also equal to 86. So I'll start by subtracting 8 from the first equation to get that p is equal to a positive 1.274. And again, on the answer key, they got a positive 1.273 just because they rounded a little differently. Then for the second equation, I'll subtract 8 from both sides to get that p is equal to a negative 17.274. And on the answer sheet, they got 0.273. However, I rounded up as opposed to just truncating or rounding down. So my solutions for number 3 are 1.274 and negative 17.274. Those are my solutions when I solve by completing the square. And if you want to double check, feel free to use the quadratic formula, and you will indeed get the same solution. Moving on to number 4, again, I'm going to move my constant to the other side of my equation. So I'll have k squared plus 8k equal to negative 12. Now I'm going to complete this square on my left-hand side by adding c. b in this case is equal to 8. So my c value, b over 2 squared, is going to be 8 over 2 squared, which equals 4 squared, which is 16. So now my equation will be k squared plus 8k plus 16 equals negative 12 plus 16, since we're adding 16 to both sides so that we do not change the value. Now, k squared plus 8k plus 16 is in the form of a squared plus 2ab plus c, where my a value is k and my b value is a positive 4. 2 times a times b, 2 times 4 times k is 8k, and b squared, 4 squared is 16. So a plus b squared equals negative 12 plus 16, which is a positive 4. So now I'll take the square root of both sides. So I'll have two separate equations. I'll have k plus 4 equal to a positive 2, since the square root of 4 is 2, and I'll have k plus 4 equal to a negative 2, since negative 2 squared equals a positive 4. Now I'll subtract 4 from each of these equations, and doing so on both sides. So I'll have k equal to a negative 2, and I'll have k equal to a negative 6. So negative 2, negative 6 are my solutions in number 4. Moving on to number 5, I'll move this constant to the other side. So I'll add 33 to both sides of my equation. So I'll have r squared plus 2r equal to 33. But I'm going to need to find that c value and also add that c value to the other side once I find it. So adding c to both sides. My b value in this case is a positive 2. So my c value is going to equal b over 2 squared. 2 over 2 squared. So c is equal to a positive 1. Now rewriting my equation above, I'll have r squared plus 2r, and I'll substitute in my value of c, which is 1, and that will equal 33 plus 1. So this is in the form where my a value is r and my b value is 1. So r plus 1 squared equals 33 plus 1, which is 34. So now what I'm going to do is take the square root of both sides. So I'll have r plus 1 equal to the positive value of the square root of 34, and I'll have r plus 1 equal to the negative value of the square root of 34. And the square root of 34 equals 5.8309, which I'll just round to 5.83. So we'll have 5.83, a positive, and a negative 5.83. So when I subtract 1 from both sides of this first equation, I'll get r equal to a positive 4.83. When I subtract 1 from both sides of the other equation, I'll get r equal to a negative 6.83. So my solutions in number 5 are 4.83 and negative 6.83. In number 6, a squared minus 2a minus 48, I'm going to start by adding 48 to both sides. So I'll get a squared minus 2a, and then I'm going to be adding c to this eventually. That will equal 48, and then adding c to that as well. Because if I'm adding c to the left, I'm going to need to add c to the right. So now let's solve for what that c value is in order to complete this square. If my b value is a negative 2, that means my c value is going to be negative 2 over 2 squared. So that's going to be negative 1 squared, which equals a positive 1. So now substituting my c value in, I'll have a squared minus 2a plus 1 equal to 48 plus 1. Now this is in the form of a squared minus 2ab, so I'm going to have a minus b squared. So that's a, since my a value is a, and my b value is 1. A minus 1 squared. That's going to equal 48 plus 1, which is 49. Now I'll take the square root of both sides, remembering to take into account my positive and my negative values. So I'll have a minus 1, and the positive square root of 49 is 7, and then I'll have a minus 1, and the negative square root of 49 is a negative 7. That's because when I square negative 7, also equals a positive 49. Or you can almost think of this as squaring the negative square root of 49. That would be equivalent to the opposite or negative square root of 49 times negative square root of 49, which we know a negative times a negative is positive, so that will give us a positive 49. So continuing on, I'll add 1 to both sides of my equation to get that a equals 7 plus 1, which is 8. Then I'll add 1 to both sides of my other equation to get that a equals negative 7 plus 1, which is a negative 6. So my solutions in number 6 are 8 and negative 6. Now if I haven't said so before, what this means when I solve for the solution, it means that I can plug 8 in for a, or I can plug negative 6 in for a, and the left-hand side of this equation will equal 0. That's what it means to solve. We're solving for the variable value that will make this equation true. Let's continue on to number 7. In number 7, I have m squared minus 12m plus 26. So I'll subtract 26 from both sides. That'll give me m squared minus 12m, and in order to complete that square, I'll need to add some c value. And then I'll have negative 26 on my right-hand side, and then I'm also going to have to add the c value to that as well. Since I added it to the left, I'll need to add it to the right. Now in order to complete this square, I'll see that my b value is a negative 12, so that means my c value will equal negative 12 over 2 squared. Negative 12 over 2 is a negative 6, and when I square that, I'll get a positive 36. So I'll have m squared minus 12m plus 36 equals negative 26 plus 36. Now this is in the form of a squared minus 2ab plus b squared. So my a value is m, and my b value is 6, because 6 squared is 36, and 2 times 6 is 12. So m minus 6 squared equals negative 26 plus 36, which is a positive 10. So what I'm going to do is take the square root of both sides to get that m minus 6 equals the positive square root of 10, or m minus 6 equals the negative square root of 10. Now I'm just going to add 6 to both sides of this equation to get m equal, and then I'll type this into my calculator, the square root of 10, close the parentheses, and then add 6 to that and get 9.162. And then I'll add 6 to the other side, so I'll take m and get negative square root of 10, typing that into my calculator, closing that parentheses, and then adding 6 to that. I'll get 2.8377, which I'll round to 2.838. So as opposed to writing the square root of 10 in decimal form, I left it as an exact value and then added my whole number on my calculator. So my two solutions in number 7 are 9.162 and 2.838. And on the answer key, they have 2.837, but I just rounded the 2.8377 up to 2.838. And now, lastly in this video, number 8. However, before I go over the answer to this, please remember to like this video and subscribe to my channel. Now, for number 8, we'll start by subtracting 20 from both sides. So I'll have x squared plus 12x equal to negative 20. Now I need to solve for the c value, which completes the square on my left-hand side. If my b value is a positive 12, my c value is going to be 12 divided by 2 squared, which is 6 squared, which equals 36. So I'm going to have x squared plus 12x plus 36, and that's going to be equal to negative 20 plus 36. Since I added a 36 to the left, I need to do so to the right. Now x squared plus 12x plus 36 is in the form of a squared plus 2ab plus b squared, where my a is x and my b value is 6. So x plus 6 squared equals negative 20 plus 36, which is a positive 16. Now, taking the square root of both sides, I'll get that x plus 6 is equal to a positive 4, or x plus 6 is equal to a negative 4, since the square root of 16 is both positive 4 and negative 4. Now, I'll subtract 6 from both sides of my first equation to get that x is equal to a negative 2, since 4 minus 6 is 2. And then I'll subtract 6 in my second equation to get that x is equal to a negative 10, since negative 4 minus 6 is negative 10. So in number 8, my final solution is negative 2 and negative 10. If you didn't do so before this problem, here's a friendly reminder to like this video, subscribe to my channel, And also, feel free to share it with your peers. Continue on to the next video where I'll complete the next 8 problems, 9 through 16. And in the last 2 of those, I'll be introducing how to complete the square and then solve the quadratic when the a value is not equal to 1. In this video, we're continuing on with the solving quadratic equations by completing the square worksheet on the KutaSoftware website under the Infinite Algebra 1 section, picking up where we left off with number 9. We're going to start by adding the constant to both sides in order to move it to the right-hand side. So adding 48 to both sides will give us k squared minus 8k equal to a positive 48. Now what we need to do is we need to complete this square that's on the left-hand side. And in order to do that, we know that that b value is a negative 8 and c is equal to b over 2 squared. And our b is negative 8, so I'll have negative 8 over 2 squared, which is a negative 4 squared, which equals a positive 16. So now we're going to add 16 to the left, and we're going to add 16 to the right. So we'll have k squared minus 8k plus 16 equal to 48 plus 16. And we have to add 16 to both sides so that we don't change the overall value of the equation. Whatever we do to the left, we need to do to the right. So k squared minus 8k plus 16 is in the form of a squared minus 2ab plus b squared, where a is k and b is 4. So we'll have k minus 4 squared, a minus b squared, because that equals a squared minus 2ab plus b squared. And then 48 plus 16 equals a positive 64. So our next step will be to take the square root of both sides. So we'll have k minus 4 equal to a positive square root of 64 or the negative square root of 64. So k minus 4 is going to equal a positive 8 or it's going to equal a negative 8. Because negative 8 squared equals positive 64 and 8 squared equals positive 64. So we'll add 4 to both sides in this first equation to get that k is equal to a positive 12. And then we'll add 4 to both sides in that second equation to get that k is equal to a negative 4. So my two solutions in number 9 are 12 and negative 4. Let's continue on to number 10. In number 10, we'll start by adding 63 to both sides. So adding 63 to the left and adding 63 to the right. So we'll have p squared plus 2p equal to a positive 63. Now we need to figure out what that c value is in order to complete this square. If b is a positive 2, then c will equal 2 over 2 squared, which is 1 squared, which equals 1. So we're going to be adding 1 to both sides. So we'll have p squared plus 2p plus 1, and then that's equal to 63 plus 1. P squared plus 2p plus 1, which we can write as a plus b, that quantity squared. So my a value is p, and my b value is a positive 1. So p plus 1 squared equals p squared plus 2p plus 1. And that is going to equal 63 plus 1, which is 64. Now, we'll take the square root of both sides. So p plus 1 is going to equal a positive 8, and p plus 1 is going to equal a negative 8. So I'll take away 1 from both sides in my first equation to get that p is equal to a positive 7. And then I'll take away 1 from both sides in my next equation to get that p is equal to a negative 9, since negative 8 minus 1 equals negative 9. So my solutions in number 10 are a positive 7 and a negative 9. And number 11, even though this doesn't equal 0, that's okay, because we're just going to add 48 to both sides, just like in the previous two problems where we're adding that constant to move it to the other side of the equation. So we'll have m squared plus 2m equal to negative 6 plus 48, which is a positive 42. Now we're going to figure out what the c value is in order to complete the square m squared plus 2m, and then we're going to be adding that c. So if b is equal to positive 2, c will be equal to 2 over 2 squared, which equals 1 squared, which is 1. So we'll have m squared plus 2m plus 1 equal to 42 plus 1. M squared plus 2m plus 1 we can rewrite as m plus 1 squared. And 42 plus 1 is 43. So I'm going to be taking the square root of both sides. So I'll have that m plus 1 equals the positive square root of 43, and m plus 1 will equal negative square root of 43, since that negative squared is equal to positive 43. And this negative is on the outside of the square root of 43 because we're taking the square root of a positive number. So taking the square root of a positive number will give us a positive solution and a negative solution. So now what I'm going to do is subtract 1 from both sides to get that m equals the square root of 43 minus 1, which I'll just type into my calculator. The square root of 43 minus 1 equals 5.557. So we'll have positive 5.557. And when I subtract 1 from both sides in my other equation, I'll have the negative square root of 43, so that negative answer, and then I'll subtract 1 to get negative 7.5574, which rounds to negative 7.557. So my solutions in number 11 are positive 5.557 and a negative 7.557. Moving on to number 12, I'll start by subtracting that constant 21, essentially moving it to the right-hand side with my other constant of 6. So I'll have p squared minus 8p equal to 6 minus 21, which equals negative 15. Now in order to complete the square, my b value is a negative 8, so my c value will equal negative 8 over 2 squared, which is negative 4 squared, which equals a positive 16. So I'll add 16 to both sides. So p squared minus 8p plus 16 will equal negative 15 plus 16. Now on the left-hand side of my equation, that's in the form of a squared minus 2ab plus b squared, which I can write as a minus b squared. So I'll write this as p minus 4 squared, since b squared, 4 squared is 16, minus 2 times a times b, 2 times p times 4 is 8p, and a squared is p squared. Negative 15 plus 16 is a positive 1. So taking the square root of both sides, I'll get that p minus 4 equals a positive 1, since the square root of 1 is 1, and I'll get that p minus 4 equals negative 1, since negative 1 squared equals 1, so the square root of positive 1 can also equal negative 1. Now I'll add 4 to both sides to get that p equals 1 plus 4, which is 5. And then I'll add 4 to both sides to get that p equals negative 1 plus 4, which is a positive 3. So my solutions in number 12 are 5 and 3. Let's continue on to the second page. In number 13, I'll be subtracting 14 at the start. So I'll have m squared plus 10m equal to negative 7 minus 14, which is a negative 21. So in order to complete the square, my b value on the left-hand side is 10, so c will equal 10 over 2 squared, which is 5 squared, which equals 25. So I'll add c to both sides. So m squared plus 10m plus c will be plus 25, and then I'll have negative 21 plus c, or plus 25. So m squared plus 10m plus 25 can be written, or simplified, as m plus 5 squared. A squared plus 2ab plus b squared equals a plus b squared. And negative 21 plus 25 equals a positive 4. Now, taking the square root of both sides, I'll get that m plus 5 equals a positive 2, and m plus 5 equals a negative 2, since the square root of 4 is positive 2 and negative 2. I'll subtract 5 from both sides to get that m equals a negative 3. 2 minus 5 is negative 3. And then in my other equation, I'll subtract 5 from both sides to get that m is equal to negative 2 minus 5, which is negative 7. So my solutions in 13 are negative 3 and negative 7. Moving on to number 14, I don't have a constant on my left-hand side. It's already been moved to my right-hand side of my equation, so I just need to complete the square. So b is equal to negative 2, therefore c equals negative 2 over 2, b over 2 squared. Negative 2 over negative 2 is negative 1, and when I square that quantity, I'll get a positive 1. So now I'm just going to add c to both sides. V squared minus 2v plus c equals 3 plus c, and that c value was 1. So I'll have v minus 1 squared equal to 3 plus 1, which is 4. Taking the square root of both sides, I'll get that v minus 1 equals positive or negative square root of 4. So v minus 1 equals the positive square root of 4, which is 2, or v minus 1 equals the negative square root of 4, which is negative 2. So I'll add 1 to both sides to get that v is equal to 3, and then I'll add 1 to both sides to get that v is equal to a negative 1. So 3, negative 1 are my solutions in number 14. Now we're going to be moving on to number 15. In 15, we're switching things up a bit. Our a value is no longer 1. So what we're going to do is divide everything by a. So dividing the right-hand side by 5 and dividing the left-hand side by 5. 5v squared divided by 5 is v squared, or 1v squared, which equals v squared, and then we're subtracting 21 over 5. So 21 divided by 5 in decimal form is 4.2, and that's going to equal 10v over 5, which is 2v. So again, 4.2 is 21 divided by 5. So now I'll complete it the same way. However, in order to complete the square, I need x squared plus bx on the same side and my constant on the other side. So essentially I need to switch this 2v and negative 4.2. So I'll do that by adding 4.2 to both sides, and at the same time I'll be subtracting 2v from both sides. You can see that negative 4.2 and 4.2 will cancel out on the left, and 2v and negative 2v will cancel out on the right. So I'll get v squared minus 2v equal to a positive 4.2. Now I'm just going to complete the square the same way I've been doing it. My b value is negative 2, and my c value is equal to negative 2 over 2 squared, which is negative 1 squared, which is a positive 1. So now I'm going to be adding 1 to both sides. So I'll have v squared minus 2v plus 1 equal to 4.2 plus 1. V squared minus 2v plus 1 can be rewritten as v minus 1 squared, since my a value is v and my b value is 1, and it's in the form of a squared minus 2ab plus b squared. And that's equal to 4.2 plus 1, which is 5.2. Now I'll take the square root of both sides. So I'll get that v minus 1 equals positive or negative square root of 5.2. So v minus 1 equals the positive square root of 5.2, and v minus 1 equals negative square root of 5.2. So what I'm going to do, I'll add 1 to both sides of each of those equations in order to solve for v. So in the first equation, I'll get v is equal to the square root of 5.2 plus 1, which is 3.280, or 3.28. And then in the second equation, if I have negative square root of 5.2 and I'm adding 1 to that, I'll get a negative 1.28. So v is equal to negative 1.28. So my two solutions in number 15 are 3.28 and negative 1.28. Let's continue on to the last problem that I'll complete in this video, number 16. If you haven't done so already, like and subscribe. So number 16, we have 4v squared plus 16v equals 65. Because that a value is not 1, I'm going to need to divide by a on both sides. So 4v squared divided by 4 is positive 1v squared, or simply v squared. And that will be added to 16v divided by 4, which is a positive 4v, and that equals 65 divided by 4, which is 16.25, or 16 and 2500ths. Now I need to complete the square on my left-hand side. So my b value is equal to positive 4, and my c value will be equal to 4 over 2 squared, which is 2 squared, since 4 divided by 2 is 2, and 2 squared will equal 4. So when I'm adding c to both sides, I'll be adding 4. v squared plus 4v plus 4 equals 16.25 plus 4. a squared plus 2ab plus b squared will be v plus 2 squared. And that's equal to 16.25 plus 4, which is 20.25. So taking the square root of both sides, I'll get that v plus 2 equals positive or negative square root of 20.25. So that means that v plus 2 equals a positive square root of 20.25, and v plus 2 equals negative square root of 20.25. So subtracting 2 from both sides in each of those equations, I'll solve for v. In my first equation, the square root of 20.25, subtracting 2 from that, I'll get a positive 2.5. And in my second equation, when I subtract 2, if I'm taking it away from a negative square root of 20.25, I'll get negative 6.5. And that's because the square root of 20.25 is equal to 4.5. So 4.5 minus 2, and then negative 4.5 minus 2. That gives me 2.5 and negative 6.5 as my solutions in number 16. If you have any questions, feel free to leave them in the comments below, and I'll get back to you as soon as I can. And if you haven't done so already, like, subscribe, and share, because all likes, all subscriptions, and all shares are greatly appreciated. In this video, we're going to complete the Solving by Completing the Square worksheet on the KutaSoftware website under the Infinite Algebra 1 section, picking up where we left off with number 17. For number 17 at the start, my a value you can see is a positive 7, so I'm going to divide both sides by 7 in order to get an a value of 1 so that I can complete the square. Now, dividing the right-hand side by 7, 0 divided by 7 is simply 0. The left-hand side, I'm going to divide 7 to each of the terms. So 7b squared divided by 7 is b squared, or 1b squared, minus 14b divided by 7 is 2b, minus 56 divided by 7 is a positive 8. Now I'm going to move that constant to the right-hand side of my equation by adding 8 to both sides. Negative 8 plus 8 is 0, and then I'll have b squared minus 2b equal to positive 8. Now I can complete the square on my left-hand side. My b value is a negative 2, and c is b over 2 squared. So that will be negative 2 over 2 squared, which is a negative 1 squared, which gives me a positive 1. So I'm going to add 1 to both sides, adding c to the left and c to the right. So b squared minus 2b plus 1 equals 8 plus 1. Whatever I do to the left, I do to the right. Adding 1 to the left, I'll add 1 to the right. So I'll be able to rewrite that as a minus b squared. However, in this case, my b in my equation is equivalent to my a value, so I'll have b, and then I'll be subtracting my b value of 1 squared. So again, what I'm doing, that's in the form of a squared minus 2ab plus b squared, which I can rewrite as a minus b squared. However, in this equation, my a value is equivalent to b, and my b value in the formula is equal to a positive 1. So this b represents the b in my equation, and this b represents the b in my formula. So I'll have b minus 1 squared equals 8 plus 1, which is 9. So I'll take the square root of both sides. That means that b minus 1 is going to equal either positive or negative 3, since the square root of 9 is positive 3 and negative 3. So for b minus 1 equal to positive 3, I'll add 1 to both sides to get that b is equal to a positive 4. And for b minus 1 equal to negative 3, I'll add 1 to both sides to get that b is equal to a -2, since -3 plus 1 equals -2. So my solutions in number 17 are +4 and -2. Continuing on to number 18, I'll start by dividing everything by 2. So dividing my left-hand side by 2 and dividing my right-hand side by 2. Dividing each of those terms by 2, 2n squared divided by 2 is 1n squared, or simply n squared. 12n divided by 2 is 6n, and 10 divided by 2 is 5. And that's all equal to 0 divided by 2, which is 0. So now I'll subtract 5 from both sides, moving my constant to the other side of the equation. So I'll have n squared plus 6n equal to a -5. Now I'll be able to complete my square on the left-hand side of my equation, since I have just my ax squared term and my bx term. So if my b value is a +6, my c value is going to equal 6 over 2 squared, which is 3 squared, which equals 9. So I'm going to be adding 9 to both sides of my equation. N squared plus 6n plus 9 equals -5 plus 9. So I'll rewrite n squared plus 6n plus 9 as n plus 3 squared. That's a plus b squared, because a squared plus 2ab plus b squared, that's the form of n squared plus 6n plus 9. And that's equal to -5 plus 9, which is a +4. Now I'll take the square root of both sides. So n plus 3 will either equal the positive square root of 4, which is 2, or n plus 3 is going to equal a negative square root of 4, which is -2, since -2 squared equals +4 and 2 squared equals +4. So I'll subtract 3 from each side of both those equations in order to isolate my n. So n will equal 2 minus 3, which is -1, and n will equal -2 minus 3, which is -5. So my solutions for number 18 are -1 and -5. In number 19, my a value is a +1, so I'm not going to need to divide. However, I need to move this constant of 22 to the other side of the equation, and I'll do so by subtracting 22. So I'll have n squared plus 13n equal to 7 minus 22, which is a -15. Now I'll complete the square on my left-hand side. If my b value is a +13, my c value will equal 13 over 2 squared, which 13 divided by 2 is a +6.5, and if we're squaring that, 6.5 squared equals 42.25. So I'm going to add 42 and 25/100ths to both sides. So I'll have n squared plus 13n plus 42.25 equal to -15 plus 42.25. Note, 6.5 times 2 is 13, and 6.5 squared is 42.25. So we'll have n plus 6.5 and that quantity squared. That's going to be equal to -15 plus 42.25, which is a +27.25. So now we're going to take the square root of both sides. So n plus 6.5 equals either positive or negative square root of 27.25. So when n plus 6.5 equals the positive square root of 27.25, subtracting 6.5 from both sides, we'll get that n is equal, typing that into our calculator, the square root of 27.25 minus 6.5 will equal -1.2798, which on our worksheet they round that to -1.279, but I'm going to round that to -1.280. So -1.280, and for n plus 6.5 equal to negative square root 27.25, I'll subtract 6.5 from both sides to get that n is equal, typing that into my calculator, a -11.7201, which rounds to -11.72. So my solutions in number 19 are -1.28 and negative 11.72. Moving on to number 20, my a value is a positive 5, so eventually I'm going to need to divide by 5. But before I do that, I'm going to add 68 to both sides. So I'll get 5n squared plus 19n equal to negative 2 plus 68, which is a positive 66. Now I'll divide everything by 5, the left-hand side and the right-hand side. 5n squared divided by 5 is a positive n squared, and I'll add that to 19n divided by 5, which is 3.8n, and that will equal 66 divided by 5, which is 13.2. Now I need to complete that square on my left-hand side. My b value is a positive 3.8, so my c value will equal 3.8 over 2 squared, which 3.8 divided by 2 is 1.9, and when I square that, I'll get 3.61. So remember that my b squared value is going to be 1.9 squared. So I'll have n squared plus 3.8n plus, and I'll leave this as 1.9 squared, equal to 13.2 plus 3.61. And I'll leave that as 1.9 squared just to show you that that is indeed the b squared value, which makes it easier when I split it up. Now, since this is n squared plus 2ab plus b squared, I can just write n plus 1.9 and that entire quantity squared. I also could have written 3.61 as 1.9 squared, but since I'm adding it to 13.2, ultimately, in the end, it doesn't matter how you write the numbers, just know that they're equivalent. So 13.2 plus 3.61 equals 16.81. So I'm going to take the square root of both sides. That means that n plus 1.9 equals the positive square root of 16.81, or n plus 1.9 equals negative square root of 16.81. So in both equations, I'm going to need to subtract 1.9 from both sides in order to isolate my n value. So in that first equation, n, when I take the positive square root of 16.81 and I subtract 1.9, I'll get a positive 2.2. And in that next equation, my n, when I take the negative square root of 16.81 and subtract 1.9, I'll get a negative 6. And that's because the square root of 16.81 equals 4.1. So 4.1 minus 1.9 equals 2.2, and negative 4.1 minus 1.9 is a negative 6. So my solutions in number 20 are 2.2 and negative 6. In number 21, I know I'm not going to need to divide. However, I need to move that constant to the other side of my equation, and I'll do so by adding 38. So I'll have r squared minus 9r equal to negative 9 plus 38, which is a positive 29. Now I'm going to need to complete the square on my left-hand side. So my b value is negative 9, so my c value will equal negative 9 over 2 squared. Negative 9 divided by 2 is a negative 4.5, and when I square that, I'll get 20.25. So adding 20.25 to both sides, I'll have r squared minus 9r plus 20.25 equal to 29 plus 20.25. So you can see my b squared value was 4.5 squared, and because I'm subtracting 2ab, I'll write this as r minus 4.5 squared, and that will equal 29 plus 20.25, which is 49.25. So now I'll take the square root of both sides to get that r minus 4.5 will equal a positive or negative square root of 49.25. So r minus 4.5 equals a positive square root of 49.25. I'll solve that by adding 4.5 to both sides. So taking the square root of 49.25 and adding 4.5, we'll get 11.5178, which on the worksheet they round to 11.517, but I'm going to round up to 11.518. So r equals 11.518, and we're going to see when r minus 4.5 equals negative square root of 49.25. So now we'll add 4.5 to both sides, and adding 4.5 to the negative square root will give us negative 2.5178, which again they rounded down to negative 2.517, but I'm going to round up to negative 2.518. So my solutions in number 21 are positive 11.518 and negative 2.518. Let's continue on to number 22. In number 22, my a value is something other than 1. So I'm going to need to divide everything by 3. However, before I do that, I'm going to subtract my constant. So I'll have 3x squared plus 20x equal to 4 minus 36, which is a negative 32. So now I'm going to divide everything by 3. 3x squared divided by 3 is positive 1x squared. 20x divided by 3 is 6.66 repeating, so I'll just leave that as 20 thirds times x, 20 over 3 times x, and that's equal to negative 32 divided by 3, which is negative 10.6 repeating. So again, I'll leave that as negative 32 over 3, so that when I type those into my calculator, within parentheses, I'll have those exact values, as opposed to a rounded value so soon within my problem. Now I need to find my c value that I'm going to add to each side. And if b is equal to 20 over 3, my c value, remember, is b divided by 2, which dividing by 2 is the same as multiplying by 1/2. So I'm going to have 20 over 3 times 1/2 squared. And that's going to be 20 over 6 squared, which 20 divided by 6 is the same as 10 over 3. And when I square 10 thirds, I'll get 11.1 repeating, so 11.111. So now I'm going to add my c to both sides. So I'm going to have x squared plus 20 thirds x plus, and then I'll put 10 thirds squared. That's going to be equal to negative 32 over 3 plus, and again, just in order to keep this as exact values, I'll write 10 thirds squared, which we know is equal to 11.1 repeating. So I can rewrite this as x plus 10 thirds squared, since it's in the form of a squared plus 2ab plus b squared, and that will be equal to negative 32 thirds plus 10 thirds squared, which is 4/10 repeating, 0.4444, which I'll leave in fraction form as 4/9. And why I'm leaving this in fraction form is because when I take the square root of both sides, I'll get that x plus 10 thirds is going to be equal to a positive square root of 4 over 9 or a negative square root of 4 over 9. I'll write it as the square root of 4 over the square root of 9, and this is either positive or negative. So x plus 10 over 3 equals a positive 2 thirds, or it equals a negative 2 thirds, since the square root of 4 is 2 and the square root of 9 is 3. So I'll solve for when x plus 10 thirds equals a positive 2 thirds. What I'll do, I'll subtract 10 thirds from both sides, and because they have a common denominator, I'll be able to subtract. So I'll get that x equals 2 thirds minus 10 thirds is negative 8 thirds, which as a decimal, negative 8 thirds is negative 2.6 repeating, so negative 2.66, and on the worksheet, they round that third value to 6, but I'm going to round up to 7. So negative 2.667. So that's solving when it's equal to positive 2 thirds. Now let's solve when it's equal to negative 2 thirds. When x plus 10 thirds equals a negative 2 thirds, we'll subtract 10 thirds from both sides to get that x is equal to negative 2 over 3 minus 10 over 3, which is negative 12 over 3, which simplifies to negative 4, since 3 goes into 12 evenly. So my two solutions in number 22 are negative 2.667 and negative 4. Moving on to number 3, my a value is a positive 1, so I'm not going to need to worry about dividing by a. However, I need to move this constant to the other side, and I'll do so by adding 45 to both sides. So I'll get x squared plus 7x equal to 7 plus 45, which is 52. So now I'm going to complete my square on my left-hand side. If my b value is 7, my c value is going to be 7 over 2 squared, which 7 divided by 2 is equal to 3.5, and when we square that, 3.5 squared equals 12.25. So I'm going to add 12.25 to both sides, that c value, so I'll take x squared plus 7x and add 12.25, and that will equal 52 plus 12.25. So rewriting a squared plus 2ab plus b squared, I'll have x plus 3.5, since 3.5 squared was 12.25, so a plus b squared equals 52 plus 12.25, which is 64.25. Now I'm going to be taking the square root of both sides. So x plus 3.5 equals positive or negative square root of 64.25. So I'll have that x plus 3.5 equals the positive square root of 64.25, and I'll have that x plus 3.5 equals negative square root of 64.25. So subtracting 3.5 from my first equation, I'll get that x is equal to the square root of 64.25 minus 3.5, which equals 4.5156, which I'll round up to 4.516. However, on the answer sheet, they round down to 4.515. So x rounding up is 4.516. And my other x value, when I subtract 3.5 from both sides, taking away 3.5 from that negative square root, I'll get that x is equal to negative 11.5156, which I'll round up to 516, and on the worksheet they round down to 5.5. So negative 11.516. So my two solutions in number 23 are a positive 4.516 and a negative 11.516. And where they rounded down or simply truncated after that third decimal place, I rounded up, or rounded to the closest. Now, let's move on to the last problem, number 24. In number 24, my a value is a positive 1. So all I need to do is move the constant to the other side and then complete the square on the left-hand side. So n squared plus 19n equals 6 minus 66, which is a negative 60. Now completing the square, if my b value is a positive 19, my c value is going to be 19 over 2 squared. 19 divided by 2 is a positive 9.5. And when we square that, we'll get 90.25. So adding c to both sides, both the left and the right of my equation, I'll get n squared plus 19n plus 9.5 squared, which is 90.25. That's equal to negative 60 plus 90.25. And if you're more comfortable leaving this as 9.5 squared so that you remember that that will be your new b value when you simplify, for instance, n plus 9.5 squared, feel free to do so, because a squared plus 2ab plus b squared equals a plus b squared. And then negative 60 plus 90.25 equals a positive 30.25. So now when I take the square root of both sides, I'll get that n plus 9.5 is going to equal positive or negative square root of 30.25, which the square root of 30.25 is 5.5. So n plus 9.5 equals a positive 5.5, or n plus 9.5 equals a negative 5.5. So we're going to solve each of these equations. And we'll do so by subtracting 9.5 from both sides in each in order to isolate that n on the left-hand side. So n equals 5.5 minus 9.5, which is negative 4, and n equals negative 5.5 minus 9.5, which is negative 15. So my final solution on this worksheet, negative 4 and negative 15. If you have any questions, feel free to leave them in the comments below, and I or one of your peers will get back to you as soon as possible. Also, if you haven't done so already, please remember to like this video and subscribe to my channel. All likes and subscriptions are greatly appreciated. So before you move on, like, subscribe, and share.